Hello everyone. In previous video we have discussed about the resonance tube. Next we are going to discuss about beats. Nowadays everyone know that what are beats. Means in functions, some of parties and in the songs also we can see the DJ sounds. The maximum and minimum of sounds by in the parties and barat nowadays. So the maximum and minimum of sound whenever the two nearly equally frequencies means the two not equal frequencies, nearly equal means different, slightly different frequencies are superimposed on another, we can hear the sound at a position, at a particular time, at a given time, a particular position, the maximum and minimum sound we can hear. That maximum and minimum sound when the variation of alternate variation of intensity of sound at a time at particular position is called beats. That means to say the phenomenon of alternate variation of intensity of sound with a time, alternate variation of intensity of sound with a time at a particular position, when two sounds of nearly same frequencies and amplitudes superimpose on each other is called beats. Here just see this, here one wave is moving in one direction with one pace, one wave in a white color, and another wave with a different frequency, slightly different frequency, means here is the slightly different frequency, here is the frequency, the slightly difference is there. So with a different frequency another wave is also moving in this direction, another in this direction, same direction with the slightly different frequencies and amplitude. So whenever after some time the two waves are superimposed at a point and we can hear the sound at zero time, we can hear the whenever two waves are in opposite pace, they both cancelled each other, so the zero of sound means minimum sound we can get, means silence. Two waves are collide and collapse. Then here the whenever after same time, a particular time 0.25 seconds, another thing, here the waves are superimposed and form the single wave, means we can hear the sound same intensity of sound for the two waves, that is at 0.25 seconds, then the maximum intensity of sound we can hear. After that again we can continue this one, after 50 seconds the minimum sound. Continuously if we hear the alternate variation of intensity of sound when the two nearly equal frequency amplitude waves are superimposed one on one another, then that means to say that is called as beats. Nowadays we are already in movies also, the songs are, the musical instruments are played, whenever they are playing that, the drums and the music, in everything is beats is there because of minimum and maximum of sound. The alternative periodic means alternative periodically, the alternative variation of sound with a particular given time, particular time and position is called beats. Here is that whenever we listen this is a maximum and minimum, whenever the waves get the minimum sound, then from that minimum sound here is the maximum sound and there minimum sound, maximum sound and minimum sound. The one completion of maximum to the minimum is called a beat, one beat. Here if we take the two waves which is having the angular frequency, that is omega 1 is the angular frequency which is greater than the second frequency, that is omega 2, means omega 1 is greater than omega 2. With the displacements, both are having the displacement, some of the 10 displacements are that S1 is equal to a cos omega t and S2 is equal to a cos omega 2t. Means here the beats means when the two waves are superimposed on one another with different frequencies, we can hear the maximum and minimum. We can say that is a waxing and waning of sound. We can hear that waxing and waning of sound, waxes and wanes. So waxing and waning of sound of alternative intensity, that sound is called, when two waves are superimposed, is called beats. Here is that beats, means the phenomenon of alternative variation of intensity of a sound with the time at a position when two sound waves of nearly same frequencies, nearly same, not equal, nearly same frequencies and amplitudes superimpose on each other is called beats. This beats is depends on the phenomenon of interference of waves. They, under the phenomenon of interference of waves, will act in beats position. Okay, so next here the displacements of waves are S1 is equal to A cos omega 1t, means first wave displacement, and the second equation for the second wave, S2 is equal to A cos omega 2t. Here is the second wave equation. Then next, when the two waves are superimposed on one another, from the principle of superposition of waves, we can get the final equation. From that omega greater than omega 2 with same amplitude A, and displacements S1 and S2, that is S1 is equal to A cos omega t and S2 is equal to A cos omega 2t. From the principle of superposition of waves, then S is equal to S1 plus S2, means the resultant displacement, which is equal to the algebraic sum of the displacements of individual waves, that is S is equal to S1 plus S2. Then S is equal to, S1 is equal to, we have the equation, that is A cos omega 1t plus S2 is equal to A cos omega 2t, A cos omega 2t. If we substitute that from the trigonometrical relation, cos alpha plus cos beta, because of it, this is the same as this formula. So cos alpha plus cos beta, cos alpha plus cos beta, whenever the A taken to the out commonly, then 2 cos alpha plus beta by 2 cos alpha minus beta by 2. From that, according to this relation, if we write this equations, then S is equal to, whenever the A taken this side, then 2 cos alpha, this is denotes with alpha, and this is denotes with beta. Here is this one is beta and this one is alpha. So cos alpha plus beta by 2 cos alpha minus beta by 2, alpha minus beta by 2, omega 1t minus omega 2t t by 2. So S is equal to 2a cos of, when the t is common, so taking outside, then omega 1 plus omega 2 by 2 into t, and cos omega 2 minus omega 1 minus omega 2 into t by 2. From this relation, we have the, whenever two waves are superimposed, then the angular frequency will be, we can hear the same equation sound. Whenever two angular frequencies are added, means the maximum sound, omega 1 minus omega 2, waning of sound, waxing and waning. Then here the omega A is equal to omega 1 plus omega 2 by 2. We are assuming that. Then omega B is equal to omega 1 minus omega 2 by 2. Let's consider that one. Then S is equal to, it will becomes 2A. The waning of sound is omega 1 minus omega 2 by 2 is omega B. So that's why omega BT. And omega cos AT, cos omega AT, then it will be the omega 1 plus omega 2 by 2. Assume that the mod of omega 1 minus omega 2 is less than or equal to omega 1, means the first wave, angular frequency of first wave is more greater than the omega 1 minus omega 2. Just assume that. Assume that, then the resultant equation with the waxes and wanes with the frequency is when the cos omega t, here is that the term cos omega bt is moved to the positive direction or in the negative direction. The maximum or minimum, the positive direction or negative direction, means either in upwards, whenever the beats will form in upwards or in downwards. When the waves are formed, downwards means when the minimum sound, upwards means maximum sound. Then here the resultant wave waxes and wanes with the frequency is 2 omega b is equal to omega 1 minus omega 2. The resultant wave waxes and wanes with the frequency of 2 omega b is equal to omega 1 minus omega 2. Then we know that from the angular frequency omega is equal to 2 pi nu. The relation between the linear frequency and angular frequency, that is omega is equal to 2 pi nu, or we already derived that equation, the relation between the time period to the angular frequency, that is omega is equal to 2 pi by t. From the relation also we can write omega is equal to 2 pi nu. So in 2 pi nu, the beat frequency will be, whenever we substitute this one in the equation, then we can get both sides will be cancelled. The omega b will become the new beat, 2 pi new beat frequency. Then 2 pi new beat is equal to 2 into 2. Then omega 1 minus omega 2, we can cancel it at the both sides. Then new beat is equal to nu 1 minus nu 1 similar to nu 2. When this is the equation for beat frequency. Once again, when two waves of slightly frequency, means a nearly frequency or amplitudes are superimposed on each other, the phenomenon of alternate variation of intensity of sound, alternative variation of intensity of sound, when two waves are superimposed with a slightly frequency, slightly equal to both are equally frequency or amplitude, then beats, that is called as a beats, the phenomenon of alternative variation of intensity of sound with time at a particular position when two sound waves of nearly same frequencies and amplitudes superimpose on each other is called beats. Whenever we take the beats which is having that angular frequency of first beat is more than the second one, then omega 1 larger than omega 2. By the taking the equations from the principle of superposition of waves, S is equal to S1 plus S2. By applying that, then we can get that this formation will be cos alpha, the trigonometrical relation cos alpha plus cos beta. From that relation we can get 2 cos of alpha plus beta by 2, cos alpha minus beta by 2. From that relation, by the calculation we can get that 2a cos of omega 1 plus omega 2 by into t by 2, cos of omega minus omega 2 by 2 into 2. Then let the omega is considered as omega 1 plus omega 2 by 2, and omega b is equal to omega 1 minus omega 2 by 2. Then from that, if we substitute these values in the equation, then we can get s of 2a, s is equal to 2a cos omega bt, cos omega at. Let's assume that omega 1 minus omega 2 is less than, more less than or equal to omega 1. Then the resultant wave axis and bands with a frequency is 2 omega b is equal to omega 1 minus omega 2. From that relation, we know the angular frequency, the relation between the angular frequency and linear frequency omega is equal to 2 pi nu. From that, we can get the beat frequency, nu beat is equal to nu 1 similar to nu 2. So here the beats will be formed. Then what are the uses of beats? What are the uses of beats? Let's when the beats are used, then the uses of beats are, here the uses of beats to determine the unknown frequency of a tuning forks. How they can be find? Means when, if we take the unknown frequency of the tuning fork 1 and another tuning fork standard fork taken, by the taking this, the n be the tuning forks what we have taken, then that here is the A with the number of vibrations per second. The standard tuning forks frequency is n, then A be the number of tuning fork, number of vibrations per second done by the tuning fork. Here it is that this is the standard frequency of the standard tuning fork. Already we know that unknown frequency tuning fork is there and known frequency tuning fork is there. So whenever we vibrate two tuning forks, that must be unknown tuning fork. Unknown frequency of tuning fork will be maybe n plus a or n minus a. Whenever that vibrates, then by filed the one prong, or some of the particles are added to the one prong, another it can be vibrated. Either if the frequency is more, frequency is not equal to the A, means the number of vibrations per second equal to A, maybe that will be the less than, means n minus A be the correct. Means whenever we taking that A beats be heard per second, then unknown frequency must be n plus A or n minus A, definitely, for the unknown frequency of sound. Then here, to decide the positive or negative one of the prong of the tuning fork of unknown frequency is loaded with a wax, and vibrated. Then that tuning fork doesn't do the same vibrations which is equal to A. If tuning forks sound together, then if the number of beats per second is greater than A, if the number of beats per second which is greater than A, then the unknown tuning fork value be the n minus A. If in case of the number of beats per second is less than A, then n plus A be the frequency of that unknown frequency of the tuning fork. Means when if we take the known frequency tuning fork and unknown frequency tuning fork, then when two vibrates at a point together, then by adding the some wax, means by adding the one prong the wax to the unknown frequency of tuning fork in vibrates, if the beats per second A is greater than A, then n minus A be the unknown frequency of that unknown tuning fork. Then if less than A, then n plus A be the unknown. Like that, by hearing that, by using the beats, we can find out the determining the unknown frequency of a tuning fork. And use in music also. Music means if the music instruments are tuning the music instruments in orchestra or another thing, if the two music instruments are doesn't have any same beat frequency, then the tune can't be clear. So that's why if the two tuning forks like sitar, two guitars must be in two equal same frequency. So that's why they will tune the same beat frequency to use by using the beats. By the beats, the tuning fork will be used. And for tuning for musical instruments, and used in electronics also, and used in mines, means like coal mines. In coal mines, when two pipes are they blow that pipe and hear the beat. In mines also, if the same sound, same frequency of sound we can get, there is no any dangerous gases are formed in the mines. If in case of for the light gases are formed, then the frequency is higher than the frequency at air, normal air. Then they detect the dangerous gases in mines by doing the difference in beats. Means if they having the two pipes, one pipe is blown at the air or in a tube, and they blow the same sound, produce the sound, means they produce the sound in air and note the beats, and the same sound beats produced in the mines. If the two frequencies are same, there is no any gases, dangerous gases inside. If in case of gas any released, then they blow the sound, that lighter gases will have the high frequency. The sound will be, beat will be high frequency, then only the dangerous gases can be detected in mines. These are the uses of beats. First, to the unknown frequency, tuning forks, and the uses in music instruments to find the tuning the musical instruments. And another one is uses in electronics and radio receivers, like that, and used in mines also, in calorie mines, coal mines, like that. So here is about the beats. Thank you.